Hey folks, welcome back. If you are attending DevOps related interviews, then this is one of the common interview questions which comes from the Kubernetes. That's what is liveness probe and readiness probe and how does it work? If this is the question you want to answer, then let's go and dive in. Before discussing about this diagram, let's jump into the documentation which I have prepared. So this documentation I have prepared on liveness and readiness probe, and I'm going to share this link in the description of this video. If you see the liveness probe, a liveness probe checks if application inside a pod is running. If the liveness probe fails, Kubernetes will kill the pod and restart it. This is useful for detecting and remediating solutions where an application might be stuck or deadlocked. So liveness nothing but it checks whether our application is running inside the pod or not. If application is stuck or deadlocked, then it is going to delete it and create the new pod. Now let's see the readiness probe. A readiness probe checks if the application inside a pod is ready to serve traffic. So over here, if it stuck or deadlocked, then only liveness probe will take action. In the readiness probe, it is going to check whether it is ready to serve the traffic or not. If the readiness probe fails, nothing but it is not ready to serve the traffic, Kubernetes will remove the pod from the pool of service endpoints until it passes. This ensures that only the healthy pods receive the traffic. In this case, it is not going to delete the pod or container inside the pod. It is just going to stop sending the traffic. And I have given example over here. Anyway, I'm going to demonstrate it. Before that, let's go and check our image once again. If you see this image, you can see in the liveness, you are going to check whether our container or application is live or not. I mean to say, is it running properly or not? If it is stuck or deadlocked, then container is restarted. If it is okay, there is no action taken. Similar lines, if you talk about readiness probe, it checks whether your application is ready to receive the traffic or not. If it is ready, then no action taken. It is going to send the traffic to that container or application. If it is not ready, then it is going to send the traffic to the alternative container. Let's assume that you have more than one pod with the same application. So it is going to route the traffic to the another container. Now let's see this in action. So to demonstrate this, as I mentioned, I am going to use this manifest file, and this is the deployment manifest file. That's why whenever we are going to do the new deployment, we should delete the existing deployment and create it. Otherwise, what happens? Though we do some modifications to our application, it doesn't come into action because deployment makes sure that you are always have the running containers or running pods in your cluster. Okay, so this is the manifest file, and if you see, I'm going to use the Apache server. This is deployment kind, and replicas I'm just creating only one, and match label Apache server. So same thing I'm going to use in the service. And here specifications, I'm using the HTTPD 2.4. This is the version. This is just for demonstration, and HTTPD by default it runs on /. That's why first I'm going to deploy the container which runs fine. There is no issue. That's why our liveness probe and readiness probe is going to get success. And if you see, it is going to send the request onto the /, nothing but just our domain name, and it runs on port number 80, so it is going to succeed. Initial delay seconds, nothing but once container is created, before testing it, it wait for 15 seconds. After that, every 20 seconds, it is going to send the request. It is kind of whether it is live or not. So if it is stuck or if it is deadlocked, then liveness probe come into action and it deletes the container and creates the new one. Now readiness probe over here, same path I'm just giving so that we make sure that our readiness probe also going to pass. And over here, initial delayed seconds, it wait for 5 seconds. After that, it is going to send the request for every 10 seconds. In case if it fails continuously 3 times, that is the default settings, so then it is not going to send the traffic. And this is the service file, so that we can validate whether our readiness is going to send the traffic to that or not. So whenever we deploy our service and if we check the describe, then there we can see whether this endpoint is matching or not, whatever pod we have created. Okay, so to demonstrate this, of course, we need a Kubernetes cluster. That is where I'm going to take advantage of Code Cloud Playgrounds. I felt this is one of the easiest way to save the time and practice the labs quite easily. So if you want to check it out, so I'm going to provide some discount coupon code in the description of this video, Valaxy 10 at this moment. That is the coupon code. If you use that, you are going to get additional 10% of discount if you want to use the code Cloud Labs. However, I have my account, so I'm going to Playgrounds. And I'm going to take the Kubernetes. So let me go with the single node or multi-node. So let me go with the multi-node launch now. So this lab is valid for 1 hour. So in case if you want to extend, there is an option. However, it is quite simple. Instead of going to AWS and setting up all the things, I felt it is convenient. Whenever I have some doubts, I'm going to just test it out, or I demonstrate it over here. I felt it is more convenient and your learning path could be easy. Alright, so this is the Kubernetes console. Now kubectl get nodes. As it is a multi-node, you have 2 nodes. Kubectl get all, you could see all the services. Let me increase the, or let me open this in the new window so that it is easy for me to see, and let me increase the font size. Okay, now I'm going to copy this one. So this is the code, right? And I'm going to create a file called liveness readiness.yaml. So I'm just copying my code, paste it, Control C, and if you see, we have liveness readiness.yaml. Similar way, we need to create a service file. So cat service.yaml. Sorry, cat greater than, right? So over here, I'm going to copy the service manifest file. Trust me, I have taken advantage of AI to just create this one. So I could see that now you can use extensively AI. If you want to know, I will make a separate video on that. Anyway, now our manifest files are ready. And yeah, quickly, if you want me to show, so ChatGPT I'm using at this moment. I will just show you my prompts as well so that it will be easy for you. And that prompt also I'm going to give it in the description of this video if you want to check it out. So this is the prompt which I have given, probes for pod and service. Little bit I tweaked. I can't use the as it is, but this is the one. So what is the liveness probe and readiness probe? Give me a manifest files for pod and service to demonstrate it. You can see here clearly it has given, but according to our lab, I just tweaked it. Anyway, I'm going to share this one also in the description of this video. If you want to check it out, you can check it out. Alright, now let's go and apply our manifest files. First, we are going to apply kubectl apply -f liveness and readiness.yaml. I haven't done any changes. It is going to work as it is, nothing but it creates the pod and it is absolutely fine. There is no failures in the liveness or readiness probe. Next, I'm going to apply kubectl apply -f service.yaml. Now kubectl get all. So it is going to display that what and all services we have created. You can see our pod is running. You can see this is the number of containers we have and how many are ready. So we have only one container within the pod and that is ready. This is where you can understand the difference between liveness and readiness probe. And restarts 0, nothing but it is fine and it is in running state. Now I can able to access this one on the 30,080. So let's access this and let's see. So service also fine. So this I need to enable in the code cloud. For that they have given a to expose, right? Yeah, view port. So I'm going to open port number 30,080. That is what we are using, right? Open port. Now you can see here it works. Nothing but there is no issue with our pod. Our pod is serving to the end users. Now just to see kubectl describe, I'm going to check my service. And you can just see here endpoint. It is referring to the pod where our application is running. Maybe this IP might be keep on changing. However, now it is sending the traffic in the backend from this service to this pod, which means that our readiness probe is fine. That's why it is sending the traffic. So in case readiness probe is fails, what exactly does it happen? It just removes this one because it won't send the traffic to this pod. If you have more pods, then it is going to send it to the other pod. Otherwise, you cannot send the traffic. So to demonstrate this one, first I'm going to make our readiness probe is going to fail. So how can I do that? I'm going to edit this one. So as you can see in the readiness probe, what it is doing, it is just going to check whether default path is accessible or not. This path, right? Sorry, where it is, where we have access. Yeah, this path. So slash nothing but after our domain, nothing is there. Now let's take that. I'm going to give test. Okay, it doesn't work because there is no path for this one, or there is no file with this name. So if you give the test, it is going to say that I didn't find. So same thing I'm going to mention in our manifest file so that it is going to fail. Okay. So some random, it could not be a test or even demo, anything. So as you can see test is not there. So I'm giving test. Now what happen if I apply this manifest file? It is going to check for this path which doesn't exist. It do 3 times, then it is going to fail. Okay. So I'm just going to save this file, not yet executed. I forgot to show you the Kubernetes, pod description as well. So kubectl get all kubectl describe our pod description. I just want to check so that you can see liveness and readiness probe is enforced. Yep, over here you can see that whether, how do you know that whether liveness probe is enforced or readiness probe is enforced on your container? So this is how you will come to know. So success, 1 success, 3 failures. In case 3 times it is failed, it is not going to send the traffic in the readiness probe. If 3 times it is failed in the liveness probe, it is going to restart the container. All right. Now one more thing I just want to show you, that is kubectl logs. Get all kubectl logs, our pod logs. I'm going to just check the logs of our pod. You can see here the code is 200 nothing but it is successful. As you can see, get, it is going to HTTP, and readiness probe and liveness probe both are fine. That's why you don't see any issue. And you can see another thing, I have applied not applied, I have updated it as a test. It is not yet applied. I don't know why it has taken it over there. But in case if you are trying to reach the path which doesn't exist, you can see here 404 error, you got it, right? 404 nothing but client side error. I am trying to access the wrong path which actually doesn't exist, that is 404. Okay, so that is what it is going to show it over here. As of now I haven't applied it, that's why it doesn't come into enforce. That's why kubectl get all, you can still see, sorry, kubectl get all, you can still see your pod is running. There is no issue. 1 by 1 and 0 restarts from 5 minutes. It is up and running. All right, I haven't applied. Now if I do kubectl apply -f and liveness and readiness probe, if I enter now, what happens? It is going to do the new deployment. Though it would do the new deployment, this pod will be up and running because we are using the type of deployment. When you do the deployment, deployment doesn't allow to do the new deployment until unless new one is ready. So over here, our readiness is going to fail, so it is not going to bring it into the live. That's why I'm going to delete the existing deployment, kubectl delete, and I will do the new deployment. Then only we can see the changes. Or else your definition should be either read replica, sorry, not read replica, uh, replica set. In case replica set, it is not going to work, just it is going to add more replicas. That's it, right? Or kind should be either replica set or pod, then only you can able to demonstrate it. Now let me apply this one once again. Before applying, let me check kubectl get all. Now you can see here your only service is running, pod has been deleted. Now I'm going to apply it once again. Kubectl apply. Now let's see the power of readiness probe. You can see, so as of now it is trying to create a container, 3 seconds only. So we have one container within the pod. That pod is not yet ready. Okay, so now let's see what happens. So now you can see, this is what you need to observe. Running nothing but the status of pod is running. Pod, there is no issue, but container is not yet ready. Why it is not yet ready? The readiness probe is trying to access the /test path, which actually doesn't exist, and it will be wait or try for 3 times, then it won't send the traffic. Won't send the traffic, nothing but you need to check in the kubectl logs, sorry, not logs, describe service, sorry, not this service, right? So in this service, previously we have seen the endpoint over here. There was a pod, right? That pod is not there. So if you see the diagram once again, this is what we are talking. So in the readiness probe, traffic is routed to the another container. At this moment, there is no another container. So it is not going to send it to any other pod at this moment. That's why endpoints are 0. Sorry, endpoints, there is no any pod IP address. Okay, now let's see again what happening over there. It is still running and container is not yet ready. And how do you know that, okay, what is the issue? In this kind of situations, kubectl logs. So this is where you need to check logs and paste it. Okay, so now you can clearly see it is trying to reach the test and 404 error. So readiness is trying to reach out to on this path, which really doesn't exist. But liveness is okay, there is no problem. That's why this container does not get restart. Now, though there is a issue with the readiness probe, but your liveness is okay. That's why it doesn't restart your container. It doesn't restart your container. All right. So that's how the readiness probe works. Now let's test the liveness probe. So again, to demonstrate liveness probe, I'm going to edit it. This time even liveness probe path also I'm going to change. So this is I'm going to give demo. Anyway, demo also doesn't exist. /demo. Just only / exist. So you can see here demo. It is giving the bad gateway, nothing but it is not even reaching to the container. So 502 nothing but client side error. Sorry, server side error, nothing but now our application is down. There is no problem with my request, whether my request right or wrong, at least it is not reaching to the application. That's why you got the 502 error, bad gateway. All right, now let's go back over here and save this file, and let me delete the existing deployment, because if I don't delete, I cannot demonstrate it. It is going to take the new deployment. It doesn't take it. If you want, you can try it out. So again, I'm just applying it. Now kubectl get all. So earlier only readiness probe was failing. Now let's see what happens. You can see here 7 seconds. Pod is running. Container is not ready because because of our readiness is unable to reach. How can we check? Kubectl logs and pod definition. Sorry, pod information. So over here, both are failing at this moment. Now, because liveness came into the picture, it has to restart our container. It has to restart our container. It tried to do that one 3 times. Okay, still it doesn't work. It will go to the error state. Let's wait, because as per our definition, okay, liveness probe, it do for every 20 seconds. Nothing but it has to test 3 times, means we need to give at least a minute for this, just to restart the container. All right, you can see here it is more than 70 seconds it identified, and one restart 7 seconds ago it tried to restart it because it cannot able to reach or do the checks. Now after 60 seconds it is going to do one more time. It is going to do one more time because now we got a new container. For the new container also it is going to do the 3 times checks. If it is failing, it is going to restart the container once again. Okay, you can see here 42 seconds ago, when it reached to the around 60-70 seconds, it is going to restart it. And kubectl get logs, and you can just monitor your logs. Yeah, unqualified domain name it is saying. Now let's see again, get logs. So second time also restarted. So it do 3 times, then instead of running, it will go to some error state. Okay, so this is how the liveness and readiness probe works. Now let me fix it and see. So now let's go over here. And even in this one, sorry. Okay, I just fixed it. Now I can do the deployment directly because existing one itself is not running, right? So there is no harm of deploying the new one. So whenever we do the new deployment, I hope it is going to take it and take the latest deployment. So kubectl apply -f liveness and readiness probe. So now we have done the new deployment, kubectl get all. Okay, now you can see here previous one anyway it wasn't running. Now it took the current one. So this is how we can able to check the logs in case something not running. And by looking at over here and over here, we can able to understand where is the problem. And over here it is not yet ready. Sorry, container is not came up. Yep, now it came up. That's why it deleted the previous one, as we have only one replica we mentioned, right? So it doesn't take this one. So we are maintaining one replica over here. This is how the liveness and readiness probe works. Now in interview, they might ask that what is liveness and readiness probe. So let's assume that in my environment, I have an application which is running inside the pod. In case that application go to deadlock state or stuck state, which it cannot able to it takes the request, but it is taking too long time. In such cases, if we want to avoid such kind of incident, I can enforce liveness so that if it is in stuck state, it is going to restart the container. Now let's assume that I have the application, but it takes a while to come up once the deployment is done. It might need to set up few things inside the container. During that time, I don't want to send traffic to that container or that part. In such cases, I can enforce readiness probe so that it won't send the traffic until unless my application is ready. So this is how you need to explain it. All right. Hope this information is useful and this video is helpful. Thank you so much for watching till this end, and resources are mentioned in the description of this video. Please go and check it out. Thank you and see you in another interesting video.